In this video, we're going to take an unknown that we were able to identify the molecular mass for at 285.9 grams per mole. And we were able to identify the mass percent of its contents at 16.1% sodium, 39.1% iron, and 44.8% sulfur. Using this, we're going to find the actual molecular formula for this unknown. So in this case, we don't have some starting options. This is a sample we obtained from some ore, so it's a new mineral. We tested it, we found some ratio of elements in it, and we're able to find a molecular mass. Given this, can we determine what the molecular formula for it is? Not just the empirical, but the actual molecular formula. Well, to start, if I want to find a molecular formula, I generally first need an empirical formula. So our first step is to find empirical. To do that, I need to find out how many moles of each element I have relative to the other elements. Well, I wasn't given a starting mass of my sample, but that's actually not a problem. I know the percentage, and that percentage is true no matter what my starting amount is. If I had 1 gram, I could say, well, 16% of that weight must be sodium, and I could calculate out what that weight of sodium was. But if I had 10 grams, well, I could still say 16.1% of it is sodium and find that, and it would just be 10 times as much. Because no matter what your sample size is, 16% of it is always sodium. I can choose any sample size I want to start with. And then just say, well, out of that, this much would be sodium, this much would be iron, this much would be sulfur. Easiest is just to pick 100. Because, hey, if you're 16.1% sodium, you're 16.1 out of 100, so that means I have 16.1 grams of sodium in that 100-gram sample. And it also means I'd have 39.1 grams of iron in that 100-gram sample, and I'd have 44.8 grams of sulfur in that 100-gram sample. So if we have the percentage but don't know the mass of the original sample, that's not a problem. You can pick whatever size sample you want to do your calculations, because that ratio is still going to be true. So picking 100 just makes our life easy. Now I can turn those into moles. If I had a sample that had 16.1 grams of sodium and 39.1 grams of iron, well, how many moles of each of those are there going to be? What's the ratio of those number of moles? For sodium, it's 22.99 grams of sodium in 1 mole. For iron, it's 55.85 grams of iron in 1 mole. And for sulfur, it's 32.06 grams of sulfur for 1 mole, which we'll find is 0.700 mole for the sodium, 0.700 mole for the iron, and 1.39 mole for the sulfur. So my sodium, my iron, my sulfur, 0.7, 0.7, 1.39. Well, my least is 0.7, so I'll divide them all by that. My sodium becomes 1, my iron becomes 1, my sulfur becomes 1.98, which is pretty close to 2. So generally we say, must be a little error in the measurements and the rounding and sig figs, so it's probably 2 sulfurs. This is often the case with mass percentages. There's a little bit of rounding error that goes into their determination. So when you do the division, if you end up just slightly off of a whole number, it's probably that whole number. Well, this, if I do the molecular mass for it, 1 sodium, 1 iron, 2 sulfur, so 22.99 plus 55.85 plus 2 times 32.06. This unit mass is 142.9 grams per unit, which basically says, 1 mole of this. Well, if I had double that, so 2 sodiums, 2 irons, 4 sulfurs, add that up, it'd be 285.9. If I had 3, so Na3, Fe3, S6, this would be 428.9 grams for the given unit, which in 1 mole would be grams per mole. Well, we said at the start we did know molecular mass. It was 285.9. That fits right here. The percent data gave us our empirical formula, saying that it's equal numbers of sodiums and irons and twice as many sulfurs. But to get to the correct mass, I actually needed specifically 2 sodiums, 2 irons, and 4 sulfurs. So this is Na2Fe2S4. So we're able to use a molecular mass and percents of each element to find the empirical formula for that material, and then use molecular mass to find the actual molecular formula. Whatever this unknown is, we've now identified safely as Na2Fe2S4.